And let me just go through and make sure that everybody is muted. Okay. Um, let's start with some important information. Today we're going to look at the tail end of the notes, mostly the trig applications. The final exam, again, I'm going to be saying this every day from now until Wednesday the 16th. The final exam is on Wednesday the 16th. It'll be available for you from 8 a.m. till 8 p.m. So it's going to have a different availability than tests have had in the past. Exam 4 is going to be due a week from today. It will be available on the 9th, on Wednesday, and it'll be available from Wednesday till Friday, and it's going to be due at the end of the day, Friday. Again, that's a little bit different than what other tests have been in the past. Homework 5.1 on angles is due on Monday. That's the radian measures and the like. Homework 5.2 is on right triangles, pretty much everything that we've done with trigonometry thus far. And homework 5.8, which is due on the 14th, is the application problems. These problems are going to be on their test, so don't wait until the 14th to do them. Problem set 4 will be due on the 11th. We will probably work through an example of that to review for the test on the 9th. And the last day that you can do anything, my math lab homework-wise, assignments, is on the 14th. After that, missing assignments will be replaced with zeros. I know that for some people it's a rude shock when that occurs. If you missed 5, 6, 7 homeworks, right now your math lab, your homework average might look okay. But if you start putting in 5, 6, 7 zeros into that average, your grade will drop significantly. So after you finish that test on the 11th, before Monday the 14th, I would very strongly suggest that you go through that weekend and do any assignment that you have not yet done, any assignment that you missed, complete any assignment you didn't finish. I know there's a late penalty, and sometimes the late penalty looks very, very severe. Sometimes with the late penalty, it looks like you're not going to get any credit for a right answer. Don't worry. After the 14th, I'm going to go through and look at everybody's My Math Lab. I'm going to look at every assignment that was turned in late, and I'm going to make sure that for every question that was correct, you get at least half credit. So don't get discouraged if it's giving you less than half credit, less than 0.5 for a correct answer. I promised at the beginning of the semester, every semester I go through and look at every late assignment and make sure that everybody gets at least half credit for each question. Does anybody have questions on any of that policy type stuff? Then next place I want to go, I want to look at My Math Lab and ask if anybody wants to look at any homework assignments. That quiz on systems, I started grading last evening. I don't think I got through all of them. They should all be done by the end of the weekend. And also, please do me a favor. Part of the reason that I really like that Blackboard grade book, probably one of the only reasons I really like that Blackboard grade book, is at any point in time, you can go in and look at it. Please take the time to look at the grade book. Make sure that there is a grade for every assignment, every test quiz that you did. If there is not a grade in there for something, please send me an email. Because again, I think I've told you that I'm grading things that are submitted in Blackboard. And if your submission didn't go in, I didn't get it, and so I couldn't grade it. And so if there's a problem like that, we still have time now to clear it up before I have to submit final grades. But I digress. Does anybody want to look at anything from any of the homework problems? If not, I'm going to add a page. We're going to go back and look at that document in a couple minutes. Last class, we were talking about finding trig function values from a calculator. And I have to just stop for a second and double check. I don't remember exactly where we left off. Did we go through and look at angles and degree measures and how to find function values? And I also want to apologize. I was unable to upload the YouTube for this class due to technical problems. So there is written notes in there, but there is in Blackboard, but last class recording is not there. So we said it was important to look at the mode to make sure we're either in degrees or radians. And I think we discussed that last class, and we looked and made sure that everybody was in degrees, and we found some function values. We said that we would round them to the nearest 4 decimal places unless we're told otherwise. So let's look at one more example. Let's find the cosine of, I'm going to do something random, 54 degrees to 4 decimal places. And so if everybody could take their own personal calculator, make sure that their calculator is in degree mode, and go through and find the cosine of 54 degrees. And to the nearest 4 decimal places, what are you folks getting? Anybody? Is anybody else getting 0.5878?
Yeah.
All right, so now I'm going to throw you a curve. Let's find the secant of 54 degrees. And I'm looking at my calculator. I'm looking long and hard. And you folks notice there is no secant there. So on the calculator, you're only going to find sine, cosine, and tangent. So in order to find the secant, you have to remember that it's the reciprocal. So it's 1 over the cosine of 54 degrees. And so to find the secant of 54 degrees, I'm going to type in 1 divided by, and then I'm going to put in my cosine of 54 degrees. And so when we take that reciprocal, and we take 1 divided by, and notice with your calculator, with most calculators, when you hit that division, it gives you a slash that actually makes it look like it's the fraction 1 over. So 1 over the cosine of 54 in degrees. Are you getting 1.7013?
Yeah, I got that.
Okay, great. And again, we knew these were all in degrees because we had the degree symbol. What if instead I asked you for the sine of 1.2? With something like this, 1.2, there's no degree symbol. It means it's in radians. And so this is where I need to change my calculator to radian measure. So I'm going to check and make sure my calculator is in radian measure. And then I'm going to clear what I have. And now in radian measure, I'm going to type in the sine of 1.2. And I get, is anybody else getting 0.9320? I'm going to look at another one. What if I want the tangent of pi over 5? Looking at that pi over 5, there's no degree symbol. So I want to make sure again that my calculator is in radian mode. And so in radian mode, I'm going to press tangent. And then I'm going to just type in using my pi key, pi divided by 5, close my parentheses. And when you do that, are you getting 0.7265?
Yeah.
And so everybody comfortable finding a function value from the calculator? You need to also be able to work backwards, and you need to be able to use the calculator to find the angle measure if you know the function value. So for example, and again, we're going to start with one that we should be familiar with. We should know, we should remember from our special triangles. But let's say I know that the cosine of my angle is equal to 1/2, and I want to find my angle. We're not going to necessarily get into the notation this semester. Those of you who are taking Math 111 next semester will find that what we're doing is we're finding, my stylus just stopped working. Give me a second. Technology at its finest. Every once in a while, the stylus stops working, and I just have to pull a battery out and rub it on my jeans or something like that. So, oh boy. Let's see if this makes a difference. There we go. What we're doing is we're finding the inverse of the function, which is a fancy way of knowing, saying we're working backwards. Usually we might say the cosine of x is equal to y. This time we want to find y if we know x, and technically we'd be saying y is the angle whose cosine is x, or the inverse. And so to get to that inverse, if you look at your calculator, we're going to press second and then the cosine button. Most calculators it's second, some calculators instead of second it might be called shift. But if you look very carefully at the face of your calculator, above the cosine in fine print, there's a cosine with an exponent of -1. Be careful, that -1 on that function means inverse, we're working backwards. It does not mean like a normal negative exponent that we're looking at a fraction. It means we're working backwards, we're taking the inverse. So I'm going to go second cosine, and then I'm going to type in 1/2, either as a fraction or you want decimal. But again, be very, very careful. The last problem that we looked at, let's find I didn't put this in there, to the nearest degree. The last problem that we looked at was radian measure. Now we want it to be to the nearest degree. And so again, whenever you do any of these trig problems, take the time to make sure your calculator is in the correct mode before you do the problem. So now I'm going to press second cosine a half, and that gives me 60 degrees. If I'm asked to the nearest tenth of a degree, let's find theta. If, let's say, sine theta equals 0.1234. Again, I know the function, I'm looking for the angle. And to find the angle, there's two things that you need to do. First thing is you need to check the mode and make sure it's all right. And the second thing, you have to remember to press second before your trig function. And so here the trig function that we have assigned, so we'll press second sine, and then our decimal, making sure we're in degree mode first. And so now I'm going to clear second sine 0.1234, and to the nearest tenth of a degree. Is anybody getting that theta is 7.1 degrees? Instead, you might also see a question that asks you to find, this time let's find to the nearest hundredth of a radian. If this time, let's say, tan theta equals 2. So again, I'm going to clear it. Check your mode. This time we want to be in radian mode. And because we're looking for the angle, we're going to press second before we press tangent. Then you'll see that exponent of -1 on your calculator display. And again, because it's an exponent of -1 on a function, it means the inverse function, not the reciprocal. So we're looking for the inverse tangent of the whole number 2. And doing that, is anybody else getting theta to the nearest hundredth of a radian is 1.11.
Yep.
Is everybody comfortable using your calculator?
I'm comfortable with it.
Great. Then let's look at some examples of problem solvings. Solve for a missing part of a triangle. And so let's say we've got the following diagram. We know it's a right triangle. If we know it's a right triangle, we know we can use our trig. Let's say we know that this angle is 29 degrees. Let's say we know that this side is 27 inches, and we want to find this side. So let's find x to the nearest 10. First thing we have to look at is where our angle is. And now that 27 we know is the hypotenuse. But let me look at x. Where is x with respect to this angle? Is it opposite or adjacent?
Is it opposite?
It's opposite. And so with opposite and hypotenuse, if I look at my memory aid, opposite and hypotenuse, is everybody all right? That's going to be sine. So I'll write that I know that sine is opposite over hypotenuse. Then I'll fill in what I know. The sine of 29 degrees is equal to the opposite side as x, and the hypotenuse is 27. Now, back in the day when I first started solving these, because I've got a fraction on one side and not the other, I kind of was always taught to think of that as being a proportion. So I'm going to think of that as sine 29 over 1 is equal to x over 27. And when I look at it as a proportion, you see I can cross multiply, and I get that x is equal to 27 times the sine of 29 degrees. And once I do that manipulation from this point in, because we're not using trig tables, we're using calculators, I just have to make sure I'm in the degree mode. Check your mode first. So I'm going to change it into degrees. And I'm going to just type in 27 sine 29. And then I'm going to round to the nearest tenth, which is going to give me 13.1. Wait a minute. You guys, we just did this totally wrong. What the hell am I thinking? Backtrack a little bit. That's not opposite, that's adjacent. And because it's adjacent, we're not going to use sine. We're going to use cosine. Sorry about that. And so instead, if I take 27 times the cosine of 29, I get 23.6 inches. And you guys can yell at me for such carelessness. So far, so good. Once we fixed it. Let's look at another one. This time, let's say that I know that this angle is right triangle. This angle is, let's say, 62 degrees. Let's say I know that this side has a length of 10. And now I'm looking for the hypotenuse. And so this time it's obvious. I hope that that's opposite. We'll get it right this time. And so we know that sine is opposite over hypotenuse. So that gives me that the sine of 62 degrees is 10 over x. And so if I cross multiply, I'd get x times the sine of 62 degrees is equal to 10. And to solve that, I have to divide by my trig function. And so x is 10 divided by the sine of 62 degrees. Again, we want to make sure that we're in degree mode. And so I'm going to take 10 divided by the sine of 62. My calculator opens parentheses when I type in my angle. It's a good habit to get in to close it. And so this time I get that my hypotenuse is 11.3. That one, all right. Then one more. This time, let's say we have a right triangle. We know that the length of this side is 10. We know that the length of this side is 29. And this time I want to find my angle to the nearest degree. Does everybody notice in this one, we're not using the hypotenuse at all? And if we're not using the hypotenuse, we're going to use tangent. But this time we don't know the angle. We do know, however, that the tangent of the angle, opposite over adjacent, would give me that the tangent of the angle is 10 over 29. That's all I'm doing, pencil and paper. Now I know the function. I'm looking for the angle. I want to make sure that I'm in degrees. I'm going to just type second tan, and I'm going to put in 10 divided by 29 to get my fraction 10/29ths. And I'll get to the nearest degree that theta is 19 degrees. That all right? Any questions?
Do you only use the inverse to find the angle that's missing?
You only press second if you're looking for the angle. If
Okay, thank you.
you just press, your function and then put the angle in. You only use that second button if you're looking for the angle. Okay?
Yes, thank you.
All right. Then, when we start looking at applications, which is a fancy pants way of saying word problems, one thing that you're going to see that some of the problems involve are bearings. And I don't mean like ball bearings or something like that. I mean bearings as a way to determine your location. Whoops. Whoops. Let's try that again. And now I know this is probably a little bit of a generational thing. Am I correct in assuming that you folks, if you're trying to look where you are and you're trying to look where you're going, you're much more likely to use GPS than a map? Yes? But when we talk about bearings, we're looking at a map. And so is everybody comfortable when you look at a map? Usually arrow pointing up is north, down is south, right is east, left is west. North, south, east, and west. And when we look at our bearings, we look at an ordered triple. And so when we look at a point, we look at an ordered pair, we have 2 coordinates. When we look at our bearings, we have 3. The first one will always be north or south. The last one will always be east or west. And the one in the middle is always going to be an angle in degrees. And this angle isn't going to be in standard position. It's going to be measured from the vertical axis. And the vertical axis would be the north-south axis. So, what does that mean? Can I scroll up?
Go ahead.
If I ask you to locate south 30 degrees west, it means that I'm going to look at an angle that's starting on the south, and I'm going to head west, and I'm going to open that angle 30 degrees. And so my location would be somewhere along this line. And somewhere along this line, we might be given a distance. Instead, if I asked you to locate something at north 75 degrees east, well, this time I'm going to start at the north, and I'm going to open my angle to the east, and I'm going to open an angle of 75 degrees. And so I would be along that line. Then sometimes it gets a little tricky. Let's say I have this diagram drawn. And let's say I have a point over here. And let's say I know this angle is 25 degrees. We'll call this point P. I want to find the bearings to point P. From the quadrant that we're in, is it obvious to everybody that we're in the southeast? Where you have to be careful with this is, do you notice that the angle that we have is not the angle that I'm going away from south to east? This middle number isn't going to be the 25, but instead it has to be the measure of this angle. And so the question I'm asking is, how do you think you would find that angle? Again, going on the assumption that my axes are perpendicular.
Would you just subtract the 25 from the 90?
Beautiful. Great. And is it obvious to everybody else that if that's the right angle, the angle that we're looking for will be 90 minus 25, which will give us 65 degrees. And so don't just always pull the angle measure off your diagram, but make sure that it's the angle that's drawn from the vertical. All right? And then in terms of word problems, another thing I want to make sure that everybody's familiar with is the relationship between the angle of elevation and the angle of depression. And so I'm going to look at a hypothetical problem. This is going to be my ground. And this is going to be something. I'm going to have one person down here on the ground. and I'm going to have somebody else up here on top of the building. And we might look at the angle of their line of sight. And so this person down here has to lift their head up to find the other person. Because they're lifting their head up, that's considered going upward, the angle of elevation. This other person, let's give them a hat just because we can. And now you guys can see why I teach math and not art. This person, if they were to look straight out to see the other person, they have to look down. And so from the top, the angle of depression would be the angle that you look down. And so you have to be careful depending on what the perspective is of your situation, of your drawing. Sometimes something like the angle of depression would not necessarily be a part of the right triangle. But the angle of elevation would be the angle of somebody's down below and they lift their head up. The angle of depression would be if somebody's up above looking straight out, and the angle that they go down from the horizontal. Both would be measured from the horizontal. And then one last thing that we'll have to be able to do if we're asked to solve a triangle. What we're being asked to do is find all the missing parts. Usually we'll know 3 parts of the triangle. And by 3 parts of the triangle, it can be any combination of angles and sides. This semester, we're always going to be looking for right triangles to solve. If it's not a right triangle, we better be able to somehow work with right triangles, because this semester we don't have a method other than using right triangle trig. So, then there are the rules. Let's start looking at problems. And so if you notice, I skipped over a page in the outline of the notes. In that page, I inserted a Word document, which is usually a handout that I use in classes of examples. And so we've got a half an hour. Let's see how many of these examples we can get through. Before I go and start looking at examples, does anybody have questions about anything that we've discussed?
Yes.
Nope.
Yes.
Was it yes to a question, or was it all across the board? No. We're good?
We're good.
So then, this document has 2 sides. Let's look first at this first problem. Let's say that the directions ask us to solve the triangles. I do believe in Blitzer's book we find sides to the nearest tenth. And we find angles to the nearest degree. Oh, you know what? I take that back. We're not solving the whole triangle. We're just looking for little b. But you know what? Why don't we go ahead and solve the whole triangle anyways, because it's in front of us. You see how we know 3 parts of the triangle. We know side C, we know angle A, and we know angle C. So if I were looking for all of the rest of the parts of the triangle, I'd need angle B, I'd need side little b, and I'd need side little a. What would you folks find first? The missing angle or the missing sides? I'm open to suggestions. Wow, you guys are quiet today.
The missing angle?
Because the triangle has to add up to 180. And because we have this right angle here, we know that A and B are complements. So angle B would be 90 minus 21 degrees, which would give me 69 degrees. Now, when I do these, I always try to make use of the given information as opposed to the stuff that I found on my own. And so if I go back, who's drawing on the picture? If I go back and look at the angle that I know, we know the hypotenuse, and we're looking for the adjacent side to find B, which was what the original question asked us for. And so to find B, the adjacent and hypotenuse tells me that I'm going to use cosine. So I'll say that the cosine of 21 degrees is little b over 238. And so cross multiplying, I'll get that little b is equal to 238 times the cosine of 21 degrees. And so then I'll take my calculator and clear it, make sure, whoops, yeah, I think I'm in degrees. I'm in degrees. Take 238 times the cosine of 21. And because we know the angle, we're just going to type cosine. And so that gives me B equals, hello. I'm looking at my answer. I know that it's not feasible because the hypotenuse should always be the longest side. I mistyped. Let's try that again. 238 times the cosine of 21 gives me 222.2 inches. And then to find little a, we have a couple of choices. One choice to find little a would be to use our trigonometry. This time little a is the opposite. And so I'll say that the sine of 21 is little a over 238, which will give me little a is 238 times the sine of 21 degrees. And type that in. And that gives me that little a is equal to the nearest tenth, 85.3 inches. Is there anybody that would have found little a in a different way?
The Pythagorean theorem?
Yep. Every semester I've got some people who prefer to use the Pythagorean theorem. I personally, at this stage of the game, prefer to use the trig because if I'm using the Pythagorean theorem, I would be making use of this rounded number that I had. But if you wanted to, you could use the Pythagorean theorem. So next question, let's follow the directions and not the made up directions. Next question, we just want to find little a. And so looking at it, does everybody see we do know three things, two angles and a side. In order to find little a, if my perspective is angle A, should I use sine, cosine, or tangent, and why? Anybody, sine, cosine, or tangent, which would you use?
Tangent,
And why?
because you're trying to find the opposite. So it would be the A over the 90.
Right. Well, or we don't have the hypotenuse, we're using the legs. And so if we're just using the legs, we'll use tangent. So the tangent of 37 is A over 90. So cross multiplying, we get A is 90 times the tangent of 37 degrees. And so again, make sure you're in degree mode. And when you take 90 times the tangent of 37, and again, because we know the angle, we're just using the straightforward tangent. And so I'm getting to the nearest tenth. It's 67.8 centimeters. Is that what you folks are getting?
Yeah.
Okay, great. Next one, and you're going to find in my labs, they usually have the pictures drawn for you, which I sort of think is sad because I think half the fun of it is drawing the pictures, but I digress. This says that a tower 100 feet tall casts a shadow 102 feet long. Please realize if you were drawing this picture on your own, we're going on the assumption that the tower is straight. No leaning towers here. Tower is straight, that's a right angle. Is everybody comfortable with the idea that the shadow is always on the ground? And if I'm looking at the angle of elevation to the sun, we're going from the tip of the shadow to the tip of the building, and the sun should be on the other side. And again, that angle of elevation is the angle that looks up. Here, they've labeled the angle theta for us. Here, we know the legs and not the hypotenuse. So that tells me I'm using tangent. Tangent is opposite over adjacent. And so that gives me the tangent of theta is equal to 100 over 102. Now, this time, because we're trying to find the angle, we have to use the inverse function. And so what I've got written here is all of the work I need to put down on paper. I'm going to clear my display and I'm going to press second tangent, 100 divided by 102. Make sure you're in degree mode first. And when I do that, I get theta is 44 degrees to the nearest degree. That one all right.
Yep.
So now, next one says, use the right triangle and the given information to solve the triangle. We know that little a is 10. Is anybody familiar with this symbol here? It's a Greek letter beta. It corresponds to a B in the Greek alphabet. And again, a lot of times you use Greek letters to represent your angles, like theta. But angle beta, this angle over here is 63 degrees. And now we want to find little b, little c. And this symbol here is alpha. And that corresponds to A in the Greek alphabet. So the angle opposite A. Notice we know three things. We've got a side and acute angle, but we also know that third angle is my right angle. What would you folks want to find first? Little b, little c, or alpha?
Alpha.
Alpha? And again, because the triangles angles add up to 180, if this is 90, the other two angles have to add up to 90. So alpha will be 90 minus 63 degrees, which gives me 27 degrees. Now, to find the other sides, let's go in alphabetical order. B is opposite the angle we know. We know the other leg, opposite and adjacent. The two legs is tangent. So I can say that the tangent of beta is little b over little a. Substituting, I get the tangent of 63 degrees is little b over 10. Cross multiplying, little b will be 10 times the tangent of 63 degrees. So I'm going to type in 10 times the tangent of 63 degrees. And again, I'm just hitting tangent because I know the angle. And so that'll give me B is 19.6. I have to apologize when I cut and paste these questions. I lost the directions. So we'll just round to the nearest tenth. Be careful when you're in my labs, they will tell you where to round, and you must round correctly. And then in order to find little c is the hypotenuse. If you wanted to, you could work with angle alpha. You could work with the sides and use the Pythagorean theorem. But again, I always, as a rule, like to use the given information and not the answers that I found, in case I made a mistake in the answers that I found. And so using the given information, C is a hypotenuse. I know angle beta. A is adjacent. Hypotenuse and adjacent tells me that I'll know that the cosine of beta is A over C, or the cosine of 63 is 10 over C. Cross multiplying, I'll get C equals, let's try cross multiplying correctly. C times the cosine of 63 degrees is equal to 10. And so I'll have to divide. C is 10 over the cosine of 63 degrees. And I'm going to just type that in my calculator. Make sure you're in degree mode. 10 divided by the cosine of 63 gives me 22.0. Is that one all right?
Yeah.
If so, let's look at this middle one. This middle one, we're trying to find this segment here, X. X is the side of the sliver of a triangle up on the top. But does everybody notice that that's not a right triangle? And we said that this semester, we're only going to make use of those right triangles. So I'm going to look at the great big right triangle, which I'm coloring red. And in the great big right triangle, I'm going to call this side Y. Then I'm going to look at the lower right triangle, which is blue. And in this blue right triangle, I'm going to find this distance which is z. And looking at the picture, does everybody see that x would equal y minus z? So first let's go through and write an expression for y. Y is in the outer triangle. In the outer triangle, that's the one with the 26-degree angle. We've got y, we're looking for y, and we've got that other leg. So we're going to use tangent. The tangent of the angle is equal to the opposite over the adjacent. And so that'll give me y equals 590 times the tangent of 26 degrees. And I'm going to stop there. Z is the opposite leg of the smaller blue triangle, which is the one with the 22-degree angle. And so the tangent of 22 is going to be z over 590. And so I'll get z is equal to 590 times the tangent of 22 degrees. And so if x is y minus z, x will be 590 times the tangent of 26 degrees. And be careful, your calculator opens a parentheses there. You've got to make sure to close it. Minus 590 times the tangent of 22 degrees. And I'm going to just type that right in so that I don't have to worry about all of the decimal places of those two separate answers. And I'm not rounding until my final answer. You don't want to round till that final answer. So I'm going to take 590 times the tangent of 26. I've got to close that parentheses that's opened. Minus 590 times the tangent of 22. Close that parentheses that's open. And I get that x, that difference, is 49.4. Does everybody see the need to use the two right triangles there and take the difference? And again, if you take the difference, leaving it in terms of the angles, you're not rounding until the last answer. And we want to only round at the last answer. You don't want to round before. Now, this next one, and I have to tell you, the homework for this course I did not create. Someone else did. This one is tricky because the side that we're given is not a side of one of the right triangles. And so in order to find this one out, we're going to try to, just for a minute, find all of the other angles. And so if this angle is 66 degrees, this angle up here would be 90 minus 66, which gives me 24 degrees. If this angle is 33 degrees, this entire angle is 90 minus 33, which gives me 57 degrees. And so this little slip of an angle is 57 minus 24, which gives me 33 degrees. And when I take the extra time to do that, is anybody else having an aha moment, realizing that if both of these angles are 33 degrees, this triangle is isosceles? And so if this side down here is 370, this side is also 370. And so I know the hypotenuse. I'm looking for the opposite. And so opposite and hypotenuse is sine. So we'll have the sine of 66 degrees is equal to x over 370. And so x will be 370 times the sine of 66 degrees. And we can type that in the calculator. There are other ways that you can get that one, all of which are very much more involved than we need it to be. And so Mr. Blitzer throws a couple of these problems into his textbook. And so be aware that if what we know is not a full side of the right triangle, check your other angles and see if you possibly have that isosceles triangle in there. I want to look at this last one. This one says a boat leaves the entrance to a harbor and travels 100 miles on a bearing of north 57 degrees east. How many miles north and how many miles east from the harbor has the boat traveled? So here is my boat. This will be my harbor. I'm going to put my bearings in there. It says I'm going from the north towards the east at an angle of 57 degrees, and I'm going for a distance of 100 miles. I'm wondering how far north I am from the harbor and how far east I am from the harbor. And in order to do that, I'm going to draw myself a right triangle. This distance, which I'll call x, is the distance north. And this distance here, that I'll call y, is the distance east. And does everybody see we can use this right triangle where we know three things? We know the right angle, one of the acute angles, and the hypotenuse to find the x and y. So if we go alphabetical order, x is adjacent to my angle. And so adjacent and hypotenuse is cosine. So I'll say the cosine of 57 is x over 100. Cross multiplying, I'll get x is 100 times the cosine of 57. Again, I want to make sure that I am in degree measures. And I get, doesn't tell me where to round to, so I guess we'll round it to the nearest mile, 54 miles. And now y is opposite. We know that the sine is the opposite over the hypotenuse. And so I'll get that the sine of 57 degrees is equal to y over 100. And I'll get y is 100 times the sine of 57, which gives me to the nearest mile, that would be 84 miles. And so we've gone 54 miles north and 84 miles east. Does that one make sense to everybody? Did I do it slowly enough or was I too fast?
I was able to follow along.
Okay, so we've got 5 minutes. I'm going to shut up and ask you guys to look at the question above. I don't think there's any below. Okay, the question above says the tallest television transmission tower in the world is in North Dakota. From a point on level ground, 1 mile, 5,280 feet from the base of the town, the angle of elevation is 20.1 degrees. Approximate the height of the tower to the nearest foot. And I'll be quiet and give you folks a minute. How are you folks doing?
I got the same answer.
Did everybody else get 1,932 feet? So how are we feeling about this right triangle trig stuff? Everybody okay?
Yep.
All right, then let's call it a day. Have a great weekend. You should be able to do all of the rest of your homework. So please do not wait till the due dates to finish them. There's also a practice test that we will go over next week. And then from there, we'll be looking at that practice final and tying up loose ends and reviewing whatever you folks feel the need for. Okay? Any questions?
Nope.
Okay, have a great weekend.
Thank
Bye-bye.
you.
You too. I just wanted to make sure you got my attendance, right?
Yeah, I did, Rachel.
Okay, thank you.
Okay, have a good one.
You too.
Bye-bye.